As you heard, I'm Jonathan Bellack. I'm a product management leader responsible for identity and counter abuse technology at Google. I've been at Google for a long time. I've been in this space more recently because I'm really passionate about helping to make the internet a slightly less horrible place. So I'm not going to come up here as the expert. You've got people like Sam and Christian from Google who know this stuff better than I ever will. But I want to give you a few ideas of how our work on FIDO and the beta that we announced last week and that Christian's going to tell you more about tomorrow fit in with more broadly how we're looking at questions of user safety. So in terms of the trends we're seeing, I'm going to talk a little bit more from a consumer point of view than enterprise. One of them, as you all know, especially in Western countries, is multiple devices per user. But I'd actually broaden this to just encourage you to be aware of multiple modalities of device usage. There are still a lot of users in the world where the phone is their only device, and they don't really have the question or the problem of multiple devices. And I would also remind you there are a lot of people in the world living in shared computing environments. We did some really interesting research on lower income people. They're often sharing a phone plan with people they don't trust for financial reasons. They're not always confident they have physical security of their devices because where they're living. The unhomed often don't have a device of their own and they're relying on shared services. So this broad range of use cases looms large as we think about what to do. Another thing that's probably obvious to all of you, but it never hurts to remind you, is that the adversaries get as sophisticated as we do. There is an awful lot of money in breaking all of this stuff. So no matter what we do to improve things, no matter what we roll out, adversaries look for new ways to attack and look for new loopholes. You think of something like FIDO, it works great when you've got your devices. If you lose all your devices, are you resorting back to a password? What are you doing? Those are going to be the little areas where adversaries are certainly going to look to exploit. And then also what users want from this whole ecosystem keeps moving. And you heard a lot of discussion about how to move people and nudge them and encourage them. Our user research has shown, at least from a consumer point of view, users don't draw a distinction between any of the words we use in the industry. Security, privacy, abuse, it all just kind of fits into this great amorphous blob of safety. Do I feel safe? Often when people say privacy, what they really mean is not having to worry about their data being hacked. They don't really see a difference. And also, very importantly, consumers have very little time that they're willing to spend thinking about these issues. It's important to them, but they have limited brain space. They're actually trying to get something else done, and they just kind of want to be reassured that they don't have to worry. They don't really want to become security experts. They don't want to know what any of this stuff means. They don't want to know from MFA, 2SV, FIDO, anything else. They just want to know if they can get their stuff done and get home to their families. Let's see. In terms of things we do, I'm not going to spend a lot of time on this, but when we're fighting abuse, as you can imagine, a lot of it is, I guess you'd call it almost to the right of boom from the earlier discussion, detection and response. Can we tell if somebody's account's been compromised? Can we tell if there's something illegal in our systems? How do we get it taken down? But more and more, we're trying to move towards protecting users up front. And that's part of what's so great about FIDO, as I've learned about it, is that ability to make phishing dramatically harder, if not completely impossible. Working across the industry is a big part of what we do. Thanks to Sam's work and others with this group, we also have something called a content safety API in the child safety space and a lot of other areas where this whole industry needs to work together to move towards more safety. And we're continuing to try to share more about what we're doing. We have a whole site full of transparency reports, sharing information, and hopefully you'll see us do more and more of that as we move forward. So with that as a background, I want to talk about two concepts that we've been working on at Google that kind of put some of this in context. One of them is a term you're going to hear a lot from us called protected computing. Jen Fitzpatrick talked about this at our I/O conference earlier in the year. And this is the notion of trying to transform the entire notion of data processing around private data so that it is dramatically more protected and users are safer by default, and having that built into multiple levels of the system. So principles of protected computing start with minimizing the data footprint as much as possible. If the data is not there, you don't have to worry about it being hacked. So how can we avoid the need to pass personal data around to servers across the network as much as possible? Edge processing, bringing more computing onto the device itself, is a huge part of this, and I'm going to talk a little more about it towards the end of this. There's also ephemerality, trying to not keep the data any longer than you absolutely need to, but this is a general trend of minimizing that data footprint. From there, there's also de-identifying data. A lot of the data that people use inadvertently can become a real source of safety and privacy concerns. So how can we make the data harder to identify, removing signals, blurring, adding noise, so that the aggregate data is still useful, but you don't have to worry about your own data being used to identify you. And then ultimately, even when the data really needs to be there, can we come up with new ways to restrict access? End-to-end encryption is pretty well known. A lot of communications products already use it. There's a lot of discussion and experimentation in other parts of computing where that's necessary. There's also some new work around the notion of a secure enclave, which is saying you can have your data encrypted, but still take advantage of cloud technology to have computing operate on your data, but in an encrypted manner so that nobody can actually see it. And if I try to explain this anymore, I'm going to get it wrong and my engineering partners are going to be mad at me. So I'm going to stop there. But it's the idea that ultimately, going back to users want safety, but they don't want to think about it. Can we just build this in as a technical default so it's simply impossible to do the things that users are concerned about? The last thing I want to touch on here is talking a little bit more about this notion of bringing things to the edge and onto the device. FIDO itself clearly does this with biometrics or screen unlocks, but this is something we've seen a lot of potential for in other areas. With the Pixel 6, we introduced phishing protections for Android Messenger in an encrypted environment so that the phone itself is helping to protect you from being phished. And I personally see a lot of opportunity in doing more in this direction. There's a lot in a helpful direction that you may have already heard of, like auto-completion and spelling correction and even translation on Pixel devices runs on the device and doesn't leak your data back to the server. I think that there's a lot more to be done to make your personal device an agent of your own safety and be working on your behalf to help make you safer. If you think of automobiles, and it was great that Bob used the unsafe at any speed analogy, car manufacturers have spent years building technology into the car to help make you safer. Anti-lock brakes, lane assist, adaptive cruise control, airbags, and on and on. Those don't require sending that information back to a server to analyze the performance of the vehicle. It's all been worked into the device itself. So imagine doing more and more of that with one's own devices. The challenge with that is that requires you to trust the device. And as I said at the beginning, the adversaries are smart and they move fast, and they're going to be looking for areas to exploit, which means the more you are reliant on your device being the way you log in, the way you verify your identity, where you're storing things, the adversaries are going to be going after the devices. And this is something we think a lot about, and I want to particularly highlight the notion of binary transparency. Hopefully you're all familiar with the idea of certificate transparency on the web, where you move to encrypted web sessions, you have a certificate indicating the encryption, and it's not just that site claiming they're secure. There are certificate agencies, there are publicly visible logs so that you can be confident that the website is who they say they are, that the certificate is legitimate, when it was issued, who it was issued by. we're trying to move phones in the same direction. And you can actually today verify pixel factory images. You can check to make sure that your Pixel device is running bit for bit the code that Google said it was supposed to have when it left the factory, and that there is a chain here for monitoring any updates. Again, if I try to get technical, my engineers are going to be mad at me. But the key point of this is that you can tell if things have been verified or have been tampered with, even as modifications happen. So as we were talking earlier about patches, as those patches come in, you can be sure that it's a legitimate patch, that you're using something that's up to date. So when the adversaries inevitably try to step in and mess around with what's on the device, you can have confidence that that is not something that you should be letting in. I mention this not just for the operating system, but to encourage everyone to think about this at different levels of technology. I mentioned this notion of phishing protections on the device in an encrypted environment. It's one thing to know that the phone itself is okay, but how do you know that that list of phishing links being used on the device to protect you is trustworthy? An adversary could come in and could remove entries to try to create a vulnerability. An adversarial regime could step in and try to add political content as an alleged phishing link to try to block people from communicating. So we've also been working to bring binary transparency down to the level of the abuse technologies on the phone, so you can have confidence if we're doing something like protecting you from phishing or trying to look for malicious software, that that is also something that you can verify all the way back. And I would encourage you to think about other layers in the system to introduce this, because what's great about certificate transparency and binary transparency is they're not just about one organization asking you to trust them. It's got this public element so that you can have witnesses. People can be checking these things, can be helping to validate them. And it brings back, just like this is a community bringing FIDO out, it helps to bring together inspection of the whole system and makes it harder for bad actors to kind of find their way in and kind of noodle about. So I know you were running late, and I promised I would try to get you a little bit back on schedule, and I think I've achieved my goal. So I will thank you very much.